All right, everyone, welcome to week 3 of our distance learning endeavor. Today we're going to look at polynomial long division. And to start, we're actually going to do some simple long division back from elementary school. So just remember your steps for long division are to divide, multiply, subtract, bring down. So in case you forget, if I'm doing 1,692 divided by 3, all right, 1692, and divide that by 3. And then I kind of cover up everything. I'm saying, does 3 go into 1? Well, no, 3 doesn't go into 1. So does 3 go into 16? Yes, 3 goes into 16 5 times. So that's the division part. 16 divided by 3 is 5. Then I multiply. 5 times 3 is 15. I subtract. 16 minus 15 is 1. And I bring everything else down. So 192. Then I repeat that whole process again. Does 3 divide evenly into 1? No. Does 3 divide evenly into 19? Yes. Well, it doesn't go in evenly, but 3 goes into 19 6 times. I multiply. 6 times 3 is 18. I subtract. 19 minus 18 is 1. Bring down the 2, and I get 12. And then I go ahead again, and I repeat the process. Divide. 3 divided by 12 is 4. 3 times 4 is 12. I subtract, and I get 0. So 1,692 divided by 3 is equal to 564. If I try that again with one more example for you, I have 10,368 divided by 12. Again, I'm saying, can I take 1 and divide by 12? No. Can I take 10 and divide by 12? No. So then I do 103 and divide that by 12. And that would be 8. So I do 8 times 12, which is 96. 103 minus 96 is 7. I bring down the 6 and the 8. Repeat the process. Can I take 7 divided by 12? No. 76 divided by 12 is 6. So 6 times 12 is 72. I subtract that. So 76 minus 72 is 4. And I bring down the 8. And now I do 12 divided by 48, which would be 4. So again, what that means is 10,368 divided by 12 is 864. Alrighty, try those two practices on your own. You can pause the video, whatever makes you feel more comfortable, how you do it. And then the next part is what happens when there's a remainder. So remember, not all the times it's going to go evenly. So let's try that out. If I do 338 divided by 4, 4 does not divide evenly into 3. 4 goes into 33 8 times. 8 times 4 is 32. I subtract that, and I get 1. Bring down the 8. Now, 18 divided by 4 is 4. 4 times 4 is 16. I subtract that and get 2. Well, 4 doesn't go into 2 either, so that means 2 is my remainder. So what I end up writing here is 84, and then I have 2 left over out of the 4 that I was trying to divide by. So therefore 84 and a half, or 84.5 is my answer. So I just took whatever that number was and divided it by whatever my divisor was. One more, 1,937 divided by 5. So 5 goes into 19 3 times. 3 times 5 is 15. Subtract that, 4. Bring down the 3 and the 7. And then 5 doesn't go into 4, but 5 goes into 43 8 times. 8 times 5 is 40. I subtract that, 3, bring down my 7. And then 5 goes into 37 7 times. Run out of space here. Just bring that up here. 7 times 5 is 35. I subtract that and get 2. So therefore now I have 387, and then I have 2 left over out of the 5 I was trying to divide by. So 387 and 2/5, or 387.4 is acceptable. All right, if we're dividing monomials now we're, again, that should all have been, elementary math. We divided by monomials earlier in the year. We really factored this a lot of times. The whole rational expressions part we did right before we left school. But if each one happens to divide unevenly, like in this case, I can divide every term by 4. Each one is divisible by 4. That's what I can do. Or you could also just take out a GCF of 4 originally, and those 4's cancel out. So in this case, I'm just dividing everything by 4. 4x squared plus 8x minus 3. Same with this one. Again, I could pull out a GCF at the top, which would be 4x, and then my 4x's cancel, or everything is divisible by 4x. So 8x cubed divided by 4x is 2x squared. 32x squared divided by 4x is 8x. And then negative 12x plus 4, or sorry, negative 12x divided by 4 is negative 3. So if you have a monomial, you can always look to just divide each monomial by it. If it doesn't work, then you have to look to factor like we did before break. So again, for the most part, this page should have been a review or refresher. Whatever problems I didn't do, so try these 2 practice problems right here, and again, these 2 practice problems right here. All right, on the back is where we get into our new stuff, the polynomial long division. And we have our steps right up here, and if you look, the steps are really very similar to the regular long division on the other side. But it's just a little bit more complicated because we have, if you look here, we have trinomials divided by binomials, and we even have, fourth powers divided by trinomials. So, all right, so step 1 is to make sure the polynomial is written in descending order. If any terms are missing, use a 0 to fill it in. So, for example, if, let's just say I didn't have my x here, let's just say I had 3x squared plus 11x squared minus 18, you want to put a 0x there. So whatever, if it's missing a variable or an exponent, just put a 0, and then whatever that x is to that power. It's just a placeholder. In this case, we have everything. It goes x squared, x in our number, so we are good. So I'm going to rewrite this as I did on the other side with the long division. All right, step 2, divide the term with the highest power in the first polynomial by the term with the highest power in the second polynomial. So my highest power here in my first polynomial is x squared. So I'm taking x squared and dividing it by the highest power of what I'm dividing by, the divisor, which is x. So if I took x squared divided by x, that is equal to x. So I put x above that x squared. Step 3 is to multiply by the answer obtained in the previous step. So I'm taking x times x, which is x squared, and then x times 1, which is x. Step 4 is to subtract and bring down the next term. So this is where it gets a little tricky because you are subtracting the entire quantity. So I put a minus, and I always use parentheses because when I subtract that entire quantity, that negative has to distribute through. So I'm really doing x squared minus x squared because I distribute that through, so those cancel out. And then negative 9x minus x, which would be minus 10x. Again, I distribute that negative sign through to both terms. And then I bring down. There's a negative 10 here. I bring that down. And I repeat my steps again. So I cover up. And now I'm really looking at negative 10x because that's my highest power. And I'm dividing that by x again. So negative 10x divided by x is negative 10. And I put that up here. And then I do the multiplication again. Negative 10 times x is negative 10x. Negative 10 times 1 is negative 10. And again, I'm subtracting. So I distribute that through. So 10x plus 10x now. Negative 10x plus 10x is 0. And negative 10 plus 10 is 0. So my remainder is 0 in this case. So therefore, if I take x squared minus 9x minus 10 and divide that by x plus 1, it comes out evenly as x minus 10. And if you were to ultimately multiply x minus 10 times x plus 1, you would get this. You would get x squared minus 9x minus 10. So it's almost like factoring. If I factored this and I knew one of my factors was x plus 1, my other factor is x minus 10. So again, if there's no remainder, it makes it a little easier because you can almost think of it like factoring. But when there is a remainder, that makes it a little bit more challenging. And we'll see some more of these examples. All right, next example, x cubed minus x squared minus x minus 2 divided by x minus 2. I do have all powers. I go 3, 2, 1, then x to the 0, so I don't have to write anything in there. So I'm going to start writing this out a while. I'm dividing that by x minus 2. All right, so again, I'm taking my very first highest exponent, which is x to the 3rd, and I'm dividing that by my highest number in my divisor, which is x. So x to the 3rd divided by x is x squared. I put that above the x cubed, and then I multiply. X squared times x is x to the 3rd, and x squared minus 2 x squared times a negative 2 is negative 2x squared. And again, I'm subtracting that, meaning I have to distribute that negative sign through. So this becomes x cubed minus x cubed, which is 0. That's good. You want those leading numbers, leading exponents to cancel out. And then I have negative x squared, and that would really be plus 2x squared. So that would give me a positive x squared, and I bring down the rest. Bring down the negative x, bring down the negative 2. I repeat the process again. X squared is now my highest number, divided by x. When I take x squared divided by x, I get x, and that'd be a positive x, so I put plus x there. I multiply x times x, which is x squared. X times negative 2 is negative 2x. And again, I am subtracting, which means I have to distribute. All right, so that would cancel out my x squareds. This would become a positive 2x, so negative x plus 2x is positive x, and I bring down my minus 2. And now I take x and divide it by x here, which is 1, positive 1. 1 times x is x, 1 times negative 2 is negative 2. And again, I'm subtracting. So I'd have x minus x is 0, 2 plus 2 is 0, so my remainder is 0. So this does divide evenly out, and I would get this to equal x squared plus x plus 1. All right. All right, 2 more examples, and they get a little bit trickier here because we're going to have some remainders for these. All right, so again, I'm not missing any exponents, so I can start writing this down. And so my first step is I take my leading number, 3x to the 3rd, or leading term, 3x to the 3rd, divided by the leading term of the divisor, which is x. So 3x to the 3rd divided by x is just 3. Alrighty. So then 3x squared. So then I take 3x squared, put that up top, and multiply that by my whole divisor. 3x squared times x is 3x to the 3rd. 3x squared times 4 is 12x squared. Just remember you are subtracting that, so that negative sign must be distributed. And 3x to the 3rd minus 3x to the 3rd cancels out. 11x squared. Now this is again going to be minus 12x squared is minus x squared. I bring down the negative 6x and the 18. And so now my leading term is negative x squared, and I'm dividing that by x. And so that would be negative x when I do that division. So I put minus x up here, and I multiply the negative x times my divisor. Negative x times x is negative x squared. And then negative x times 4 is negative 4x. Just remember you are subtracting that, so you must distribute that negative sign through. So we end up with, now become positive x squared, so those x squareds cancel, which is what you want. This becomes positive 4x. So it'll be negative 6x plus 4x is negative 2x. Bring down your negative 18. And I would then do negative 2x divided by x, which would be negative 2. I multiply negative 2 times x is negative 2x, and negative 2 times 4 is negative 8. We are subtracting that. So again, that means I have to distribute here. So my 2x's are going to cancel because that'll make it positive 2x. This is going to become positive 8, so negative 18 plus 8 is negative 10. And so my remainder is 10 here. So the way I'm going to write my answer is I'm going to have my, whatever I have up here, 3x squared minus x minus 2. And then if you kind of recall how we did the remainder on the other side, we took whatever the remainder was, that was our numerator, and our denominator was the divisor. So I'm going to do the same thing here. My remainder is negative 10, so I'm going to put minus 10 over x plus 4. And if you wanted to put plus negative 10 over x plus 4, that is fine as well. But you're putting whatever your remainder is on the numerator, where the divisor was on the denominator. All right, last example. Notice we're now having a fourth power divided by a trinomial. So we'll see how to do that. I'm not missing any exponents, so I'm just rewriting it. Remember, if you were missing an exponent, you must write that with a 0x to whatever power it is missing. And so now I'm dividing that by x squared plus 2x minus 3. So I look at my leading number, x to the fourth. My leading number for the divisor is x squared. X to the fourth divided by x squared is x squared, and I put x squared up here. So now I multiply x squared times x squared is x to the fourth. X squared times 2x is plus 2x to the third. And then I do x squared times negative 3 is negative 3x squared. Don't forget you're subtracting that, so you must distribute that negative sign through. So I really have x to the fourth minus x to the fourth, which is 0. Negative x to the third minus 2x to the third is minus 3x to the third. And then this becomes positive 3x squared. So that would be minus 7x squared. I bring down what I have left, which is plus 7x and plus 3. So now my leading term is negative 3x to the third. And I'm dividing that by my leading term of my divisor, which again is always x squared for this problem. So when I do that division, I get negative 3x. So I put that up there. And now I multiply negative 3x times x squared. It's negative 3x to the third. Negative 3x times 2x is negative 6x squared. And negative 3x times negative 3 is plus 9x. Again, I'm subtracting that whole quantity, so don't forget to distribute that negative sign through. So that makes negative 3x squared plus negative 3x to the third plus 3x to the third, which is going to cancel. This becomes positive, so negative 7x squared plus 6x squared is negative x squared. And then this becomes negative 9x, so it would be minus 2x, and I bring down my 3. I'm almost done. I would take now my leading term, which is negative x squared, and divide that by x squared, which is negative 1. And again, I multiply. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times negative 3 is positive 3. When I do that subtraction and distribute that through, I get x squared plus x squared, that cancels. Negative 2x plus 2x, that cancels. And then 3 minus 3, so I get a remainder of 0. So this does divide in evenly, and my answer would end up being x squared minus 3x minus 1. Okay, just a couple quick reminders. Again, always Remember that you're going to have every exponent. If you are missing an exponent, put a 0 next to that exponent you're missing. Always remember to subtract the entire quantity so you get to distribute. And always remember to multiply whatever you're doing times all the terms that you are dividing by. All right, we're available for office hours. Just reach out. Have a good week.